Before you watch the video, subscribe it, click on the bell icon for more notifications. Hi everybody, welcome to AGAAA-MATH. This is Rakesh. Today we are going to learn about the applications of quadratic equations, problems on time and speed. And the question is here. A fast train takes 3 hours less than a slow train for a journey of 600 kilometers. If the speed of the slow train is 10 kilometers per hour less than the fast train, find the speed of the two trains. So if we study the question here, a fast train takes 3 hours less than the slow train. So these are the, like he's saying, the difference between the two trains. That the time fast train takes 3 hours less comparing with the slow train at the journey of 600 kilometers. And if the speed of the slow train is 10 kilometers per hour less than that of the fast train. The speed of the slow train is 10 kilometers per hour less than the fast train. So find the speed of two trains. Here we do that. So he given the condition that the speed of a slow train is 10 kilometers per hour less than the fast train. Then what about the speed of the fast train here? We don't know. So then that to be taken as something variable here. So the speed of the fast train, equals to x kilometers per hour. Because if we know the speed of the fast train, it is easy to find the speed of the slow train. Because the condition is given that slow train speed is 10 kilometers per hour less than the fast train. So here slow train, the speed of the slow train now, that equals to x minus 10. This is the speed of the slow train, because 10 kilometers per hour less than the fast train, right? What is the distance here? Because here the distance for the two trains is nothing but 600 kilometers. It's a journey of 600 kilometers, right? So here the distance equals to 600 kilometers. Distance equals to 600 kilometers, right? So and in the question itself given, fast train takes 3 hours less than the slow train for a journey of 600 kilometers. It means the difference between the two trains, that is time, the difference of time in between two trains is 3 hours, right? So let's take coming to the here, what I do is slow train, right? Here I write about the slow train, and here I write about the fast train. The slow train speed, what we have taken? X minus 10 kilometers per hour. X minus 10 kilometers per hour. Right? And distance is 600 kilometers. And coming to the fast train, speed is x kilometers per hour and the distance is 600 kilometers, right? Now if we observe that time is nothing but distance over speed. It's nothing the distance by speed, so distance is 600 by x minus 10. observe one thing here, the speed is kilometers per hour and the distance also in kilometers. So that to be observed clearly. So here even time is equals to, for the fast train, there is distance is 600 kilometers and speed is, so time is equal to distance by speed, right? So here again I write distance by speed, it's nothing that 600 over x. So this is the hours and this is the hours taken by the two trains, different two trains. And what is the difference of these two trains? Fast train takes 3 hours less, means the difference between these two trains timing is 3 hours, right? 3 hours. So remember, the time for the slow train is 600 over x minus 10 and for the fast train is 600 over x. So here I take difference or time difference, right? Time difference is how much? 3 hours, right? So time difference equals to 3 hours. Okay, so the slow train will take more time. So what is the slow train time? That is 600 by x minus 10. So 600 by x minus 10, this is the time taken by the slow train, and 600 by x, this is the time taken by the fast train. So the difference is 3 hours, right? Now we have to calculate this. If I observe the denominator of this LHS part, so it's like x of x minus 10 will be the, right? Now x minus 10 is common, so I have to multiply this x with the numerator 600. So that is 600x times minus x is common, so I have to multiply with 600 of x minus 10 equals to 3. Now the next, it is 600x minus 600x plus 6000, that is 600 into x, 600x minus 600 into minus 10 plus 6000. Okay, so and equals to, here the denominator it was transferred to the RHS, so 3 of x minus 10 of x. Now if I simplify more, plus 600x minus 600x, that's nothing that equals to 0. Okay, now and we have here that is 6000 equals to, if I multiply 3x minus 30 of x, 3 into x is 3x, 3 into minus 10 is minus 30 and x. Now if I simplify more, that is 6000 equals to x into 3x, this x is multiplied to 3x, so 3x into x is 3x square minus 30x, right? So I would like to write into quadratic equation, that is 3x square minus 30x, and this transfer towards the RHS, that becomes minus 6000, sorry, this is 30x minus 6000 equals to 0. Now this is in the form of a quadratic equation, right? So what is the quadratic equation here? That is 3x square minus 30x minus 6000 equals to 0. Okay. Now if we observe here, that is in all the 3 terms, I think we can divide each term with 3, right? So if I divide each term with 3, so 3x square by 3, it means here x square remains and minus 10x, and here also divided by 3, it is minus 2000 equals to 0. So now we have to find the roots for this quadratic equation, so that we'll get the value of x, right? So the final quadratic equation is x square minus 10x minus 2000. Okay, x square minus 10x minus 2000. So that is x square minus 10x minus 2000 equals to 0. This is a quadratic equation. Now I'd like to factorize this to find the value of x. So how do I do? That is x square minus 50x plus 40x minus 2000 equals to 0. So in this x is common, so x minus 50 plus 48, if I take common, x minus 50 equals to 0. So what is common again here? X minus 50 is a common. So what is left? That is x plus 40 equals to 0. So what do we have now? X equals to 50 or x equals to minus 40. So the speed never been negative, right? So I consider the speed is 50. That means x we have taken that for the speed of what? Speed of the fast train. Here we can see the speed of the fast train equals to x kilometers per hour, right? So here speed of the fast train is x and the slow train is x minus 10, right? In that case, according to this, here I can write speed of fast train, speed of fast train equals to 50 kilometers per hour, and the slow train equals to, that is 50 minus 10 means 40, 50 minus 10, that is x minus 10, right? That is 40 kilometers per hour. So here these are the speeds of the two trains. So this is how children, how to find the time or distance or speed. However, these are the questions. This is a question related with the quadratic equation about the time and speed. Let us have one more question also, so that you feel better in understanding. I would like to come with one more question. Here we see the next question. A plane left 30 minutes later than the scheduled time, and in order to reach the destination 1500 kilometers away in time, it has to increase the speed by 250 kilometers per hour from the usual speed. So find its usual speed. Okay, so here let us see how to solve this, right? So we don't know what is the actual speed, that is the usual speed of the plane. So let the usual speed of this plane, let the usual speed equals to x kilometers per hour. So remember that always we use a unit to measure the speed, that is kilometers per hour or meters per second, but according to this given question I am using kilometers per hour, right? Then so it is already 30 minutes late, right? A plane left 30 minutes later than the scheduled time. So in order to reach the destination, it increased its speed, right? So then when it is increased the speed, what happened? After increasing the speed, the speed becomes, increase the speed by 250 means its usual speed is x and plus again it is increased of 250. So this becomes the speed. Okay, now the question to find what is the usual speed here. The distance is nothing that, what is the distance it has to travel? That is 1500 kilometers. Okay, and here you can, what is the time difference? Time difference is 30 minutes. Time difference, because it has started 30 minutes later. So obviously the time difference is 30 minutes. 30 minutes. I would like to represent in hours because here the speed is in kilometers per hour and the distance is in kilometers, so usually the time is also to be in hours. So 30 minutes is nothing but half hour, right? 30 minutes is nothing but half hour. So this is the difference time. Okay, so now as it is a difference time, let us see now. Here that is speed, actual the speed is x kilometers per hour, but when it is increased to 250 kilometers per, like x increased by 250 kilometers per hour, the time the difference as it's covered, the time difference is 30 minutes. Now let us see that is how to find. So actually time is equal to distance by speed, right? So time is equal to distance. If I compare with usual speed, the distance is 1500 and the time is x. And if I compare with the increased speed, so the distance is 1500 and the time is speed is x plus 50, because distance by time, here time is equal to distance by speed. So distance by speed, that is equals to half an hour, right? So it is 1500x minus 1500 by x plus 250 equals to 1 by 2, right? Now here we see then let's go to the next. So remember that 1500 over x minus 1500 over x plus 250 equals to half. So here I write the same equation here. 1500 over x minus 1500 over x plus 250 equals to half. So when I would like to simplify this more, the denominator is x of x plus 250. So now it is x is common, so 1500 times of x plus 250 minus x plus 250 is common, in this case 1500 times of x equals to half. Now if I were to solve more, that is 1500 times x, 1500x plus 1500 into 250, 1500 into 250, that is we get 3,75,000 or 375,000 minus 1500x equals to half of this. Both I multiply, x times of x is x square plus 250x, right? When I transfer this side to towards RHS, it's get multiplied. Now here plus 1500x and minus 1500x, that is equals to 0, so that got eliminated, and here 375,000 and it's a by 2 coming this side. Okay, so then when I multiply this with 2 and equals to, this becomes x square plus 250x. Nothing here, the denominator to transfer this side, it's get multiplied. So what we get here is, it is 3,75,000 means it is 7,50,000 equals to x square plus 250x. So finally if I write, what I get is x square plus 250x minus 7,50,000 equals to 0, right? Now let us solve this. What equation we got here? X square plus 250x minus 7,50,000, right? X square plus 250x minus 7,50,000. Here now if we factorize that, this we get as a x square, okay, x square, okay, then I can write it as, when I would like to factorize, that is 1000x, yeah, I got plus 1000x minus 750x minus 7,50,000 equals to 0. So then after, finally I can here, what I do is, if I take x common, x plus 1000 minus, if I take 750 common here, even this is also x plus 1000 equals to 0. So if I observe more here, what I get is x plus 1000 of it is x minus 750 equals to 0. So then after, here I knew that x equals to minus 1000 or 750, that is 750, right? So then that is x is nothing but speed, so speed it never been negative. So here we have to consider that usual speed of plane equals to 750 kilometers per hour. Fine. So this is how we solve the applications of quadratic equations that's related with the time and distance, right? We come with one more question finally, so I hope that will help you more, okay, in understanding quadratic applications, problems on time and speed, right? Here we are with the next question. Two trains leave New Delhi railway station. The first train travels due west and the second train due north. The first train travels 5 km per hour faster than the second train. If after 2 hours they are 50 km apart, find the average speed of each train. So here let us see how to find the speed of each train. Okay, so here I come with an explanation. So here we are, that is, let's take that this is east side and the west, north and the south, right? So the first train travels due west, so let's, the station is here, so the first train travels due west means it is traveling at this direction, okay, and the second train travels due north, so the second train travels due north, so think that this is the second train towards due north. And what they said is the first train travels 5 km faster than the second train, right? The first train, okay, travels 5 km faster than the second train. That means we don't know exactly what is a second train, so here I take that speed of second train, the speed of second train equals to x kilometers per hour, and so that the first train becomes faster than the second, that is x plus 5 kilometers per hour. This is the speed of the first train, right? So here I indicated the first train with yellow and the second train with blue, so that here the speed of this is x plus 5 kilometers per hour, right? And here the speed of the second train is x kilometers per hour. If after 2 hours they are 50 kilometers apart, so imagine that this is 2 hours it's traveled and even this also traveled for 2 hours. Now the distance between these two trains is 50 kilometers. So this is how, this is the distance, that is 50 kilometers. We know that angle exactly between the north and west, if you take it, is 90 degrees, right? So if you observe here, it appears like a right angle triangle. And if you find the distance, here we have the speed is x plus 5 and the time is 2 hours. So that is the first train. So overall the time taken by the two trains, that is 2 hours. So now let us see distance traveled by the first train. Distance traveled by the first train, that is equals to, distance is equals to time into speed, that is time times speed. So time is 2 hours and the speed is x plus 5. And the second train, distance traveled by the second the train is what? That is the same time into speed, that is 2 times of x. And if you see the distance between them, that is the difference, is 50 kilometers apart, right? 50 kilometers apart. Okay, so here what we do is, now how the gate atlane undani. తొందరగా కూర్చో. సైలెన్స్ ఉండాలి, అందుకే రికార్డ్ చేస్తుంది. తొందరగా కూర్చో. బ్యాగ్ తీరా, అర్థమే కావట్లే వాడికి. God. Now here we got that is distance that is 2x plus 10 kilometers, and here it is 2x kilometers. Okay, so as it is a Pythagoras theorem, here I applied Pythagoras, that is 2x plus 10 whole square plus x square equals to 50 square. So if I simplify more, I get a square plus 2ab plus b square, that is 4x square plus 20x plus 100 plus x square equals to 2500. Then we simplify more, so that is 4x square plus x square, it's nothing that 5x square plus 20x plus 100 equals to 2500, right? Now I do more, that is 5x square plus 20x plus 100, and this transfer, that is this is minus 2500 equals to 0. So if I simplify more, that is I get 5x square plus 20x minus 2400 equals to 0. So now each term I divide with 5. I divide each term with 5. So what I get then, if I do that, I get x square. So 20 divided by 5 is nothing that 4 minus 5, 4, 20 and 5, 8. So that is 480 times equals to 0. So now we have to factorize this x square plus 4x minus 480. Right? So is I'm right? 2400. Right? So now here if I factorize, what I get is x square plus 24x minus 20x minus 480 equals to 0. So if I do more, that is in the first two terms the x is common, so that is x plus 24 minus 20 is common, so even that it becomes x plus 24 equals to 0. So finally what we got here is x plus 24 of x minus 20 equals to 0. So that is x equals to minus 24 or x equals to 20. So the speed never be in the negative, right? So the speed never be in the negative, so that here we calculate 20. Okay, so if you see here that we have taken that the speed of the second train is x, right? The speed of the second train is x. So here speed of the second train, speed of second train equals to 20 kilometers per hour, and first train equals to what we get, that is x plus 5. It means 20 plus 5, that is 25 kilometers per hour. So here this is a way how do we find time and distance, and how do we use quadratic equations to find the relation, like to find the value if anything is given. And I hope you all understood. If you have any doubts, just give us a mail at askagaamath@gmail.com. Thank you for listening. See you. Take care. Bye bye.